Welcome back. In this video, we're going to start chapter 9, which is about quadratic equations and functions. As always, it's a good idea to look ahead at each of the sections and see just what it is we're getting into as we get into it. So, as I said, chapter 9 is about quadratic equations and functions. This chapter has a total of 8 sections. We may not do all of it, and that's fine, but just take a quick look. Sections 9.1 through 9.3 all start out by saying solve quadratic equations. 9.1 says using the square root property. That's going to be the subject of this video. Completing the square, and then the quadratic formula, yet another video. So basically 3 different ways of solving quadratic equations. 9.4 says solving quadratic equations in quadratic form, which we'll have to see what that is when we get there. But in short, it's basically using the techniques we learned in the first 3 sections to help us with equations that aren't quite quadratic. 9.5, solve equations or applications of quadratic equations. That's going to be story problems that lead to quadratics. And then 9.6 and 9.7 have to do with graphing. And how do you graph a quadratic function? What does the graph look like? And all the kind of important characteristics. 9.8, quadratic inequalities. So if you take a quadratic equation, erase the equal sign and replace it with a greater, less, greater than or equal, or less than or equal, what happens? That's what the last section is about. The first 3 sections are kind of the heart of the chapter, really. They're about how to solve quadratic equations. And we will start with 9.1 on solving quadratic equations using the square root property. So we've already seen how to solve certain kinds of quadratic equations, provided that we can factor one side. So here, for example, if we had the equation x squared minus x minus 6 equals 0, on that, the left-hand side factors. That's x minus 3, x plus 2, 0. And then we can apply the zero product property to say, well, if this is true, then it must be that x minus 3 is 0 or x plus 2 is 0. So one or the other of those 2 statements is true. And so it could be that x is 3, or it could be that x is negative 2. So 2 possible solutions. We found that using the zero product property. So the issue is, what do you do if you can't factor the one side? So if we had x squared minus x plus 11, for example, 0. Well, that one we're not going to be able to factor. So are we just completely out of luck, or is there some other way of doing it? It turns out that every quadratic equation is going to have 2 solutions, and we're going to be able to find them by the end. We can't always factor, and that's okay. We're going to learn more methods of getting this done. The first one is the square root property, and that's what this first section is about. So the first thing to do is to take a look at just what the square root property says, and then we'll apply it to help us solve certain equations. So here's the square root property. It reads like this. If x squared is equal to k, here k is a number in all likelihood, if x squared is equal to k, then x is equal to the square root of k, or x is equal to the opposite of the square root of k. Sometimes we'll abbreviate this by saying x is equal to plus or minus the square root of k. So here's a little example, an easy one. If x squared is equal to 9, then x is equal to the square root of 9, which is 3, or x is equal to minus the square root of 9, which is negative 3. We might write that as, for short, as x is plus or minus 3. If you're using like an online homework or something to get the problems done, most often you'll have to write out the 2 numbers separated by a comma. But if you're doing this on paper, then you can write x is equal to plus or minus 3, and that's okay. All right, so let's try using that square root property to help us solve this equation. X squared minus 48 is equal to 0. So what I would do first is isolate the x squared part, just using algebra. X squared will have to equal 48. Okay, so now if x squared is 48, then that's going to mean that x is equal to the square root of 48, or x is equal to minus the square root of 48. All right, so then I should figure out what the square root of 48 simplifies to. Let me do that over here on my scratch paper. 48, I want to look for any perfect square factors 48 has, and I can think of 16. 16 times 3 will make 48. So we'll have the square root of 16, the square root of 3, and that's 4 square roots of 3. All right, so then continuing on with our main work, x is equal to 4 square root 3, or x is minus 4 square root 3. If you want to use plus or minus sign, plus or minus 4 square roots of 3. All right, so there's our two solutions for that. All right, here's one for you to try. Take a minute, pause the video, try this one yourself, and then restart the video and see how you did. All right, so let's see how that went. So the first step would be to rewrite that as m squared equals 27. And then we'll be able to say, well, then it must be that m is the square root of 27, or m is minus the square root of 27. Sorry, Zoom is crashing once again. Sorry about that. So we're going to need the square root of 27. And so factoring 27, we'll write that as 9 times 3. That'll give us the square root of 9, the square root of 3. And so that is 3 square roots of 3. All right, so then m will be 3 root 3 or minus 3 root 3. If you want to use the plus or minus symbol, you can write plus or minus 3 square roots of 3. Okay, so that is our first two examples illustrating the square root property. That's much of it right there. What all the rest of this is going to be is kind of maybe progressively more complicated examples, but the main concept of the section we're done with, square root property. All right, solve 2y squared equals 98. Before applying the square root property, you want to isolate whatever is being squared here. So I'm going to divide both sides by 2. That will make it so that y squared is 49. Okay, so then that means that y is plus or minus the square root of 49. Y will be plus or minus 7. If you want, write negative 7, 7 for that. Here for this example, I just went straight to the plus or minus symbol. I hope that's okay with you. Okay, let's try more. For this one's going to be a little neat because we have x squared plus 12 equaling 0. So when we subtract 12 from both sides, we'll have x squared is equal to negative 12. And so we're going to end up with complex number answers for this. So we'll have x is minus the square root of negative 12, or x is plus the square root of negative 12. So we're going to need the square root of negative 12. So square root of negative 12. We're going to factor the inside in the radicand into perfect squares and everything else. So negative 12 is 4 times negative 1 times 3. We'll write that as the square root of 4, the square root of negative 1, the square root of 3. That will give us 2i square root 3. Okay, remember I is the square root of negative 1. So then for this, x will be minus 2i root 3, or x will be plus 2i root 3. As a reminder, there's a couple of places where it's okay to put the I. Here I've put it in front of the radical. If you wrote this as negative 2 root 3i, or 2 root 3i, then that's perfectly okay. Just make sure that you don't let the I get underneath the square root sign. So if you had 2 root 3i and the I is underneath the root sign, that's incorrect, okay? The I is not part of the radicand. That's part of the reason I usually put the I in front of the square root sign so it doesn't kind of slip under the square root sign. Okay, a couple of complex number solutions. Okay, we have more. Here's one for you to try. This one has got a fraction in it. the steps you'll want to follow will be to isolate the squared part and then apply the square root property to solve. Okay, so let's take a look. What I would do first is subtract 4 from both sides. So we'll have 1/2 x squared is equal to 20. Now to clear the fraction out, we're going to multiply both sides by 2. So that means that x squared will be 40. So from here, it will get a little more familiar. X will be minus the square root of 40, or x will be plus the square root of 40. And then we need this square root of 40. So 40 is 8 times 5, or 4 times 10. 4 times 10 is probably a better way to go. Okay, so that will be 2 square roots of 10. So x will be negative 2 root 10, or x will be positive 2 root 10. Okay. Moving on. Here we have 5r squared minus 2 is equal to 34. We're going to first isolate the squared part and then apply the square root property. So we'll have 5r squared equals, after adding 2 to both sides, we'll have 36. Then we're going to divide through by 5. So we get r squared is 36 over 5. That means that r is minus the square root of 36 fifths, or r is plus the square root of 36 fifths. And then, once again, I'll need to simplify that square root of 30. Okay, sorry about that, Zoom crashing again. So we have the square root of 36 fifths that we're going to need to simplify. So I'll use a property of radicals to split that into root 36 over root 5. And then that will be 6 over root 5. A lot of times people like to rationalize the denominator. So we're going to multiply the numerator and denominator by the square root of 5. This will give us 6 root 5 over 5. So here r will be plus or minus 6 square roots of 5 over 5. Okay, in the next one, we have a binomial that is being squared. We have 3, y minus 3 squared equals 54. So once again, we're going to want to pause the video, try this yourself, and then restart the video and see how you've done. All right, so here, my first step to get the squared part isolated would be to divide both sides by 3. So we'll have y minus 3 squared equals 54 divided by 3 is 18. So y minus 3 squared is 18. That means that y minus 3 is minus root 18, or y minus 3 is plus root 18. So we're going to need the square root of 18 for this. So square root of 18, 18 is 6 times 3, or 9 times 2. I like 9 times 2. That's the square root of 9, square root of 2. And so that will be 3 root 2 for that. So we'll have y minus 3 is minus 3 root 2, or y minus 3 is plus 3 root 2. And then adding that 3, we'll isolate the y. So we'll have 3 minus 3 root 2, or 3 plus 3 root 2 for our two solutions. Okay, we are almost done, just a couple more examples. Oh, 4 more, sorry. So for this one, next one, the squared part is already isolated. We have x minus 1/2 squared equals 5/4. So we'll start by applying that square root property. So we'll have x minus 1/2 equals plus or minus the square root of 5/4. All right, so now we're going to want to add the 1/2 to both sides. So x will be 1/2 plus or minus the square root of 5/4. And I should simplify that square root of 5/4 some. So let's do that. Square root of 5/4, that will be the square root of 5 over the square root of 4. And the square root of 4 we know is 2. So we'll have root 5 over 2. So then our x will be 1/2 plus or minus root 5 over 2. Okay, if you want, you can combine those since the denominators are both 2's. If you want to make that 1 plus or minus the square root of 5 all over 2, you can do that. But that's kind of personal preference, whichever you would like. Either one is okay. All right, so next we'll have 5. W minus 5 squared plus 4 is 104. So again, what I would do to begin with would be to isolate the squared parts. So to do that, we'll first take away 4 from both sides. That will give us 5w minus 5 squared equals 100. Dividing both sides by 5 will give us w minus 5 squared is 20. And then we need the square root of 20 for this, aren't we? So the square root of 20 is going to be the square root of 4 times 5. That's the square root of 4 times the square root of 5, or 2 square roots of 5. So we'll have w minus 5 is plus or minus, and the square root of 20 we saw was 2 square roots of 5. To finish, we will add 5 to both sides. W is equal to 5 plus or minus 2 square roots of 5. In our next example, the left-hand side is 3k plus 4 squared. The right side is -8. So we're ready right now to apply that square root property. We'll have 3k plus 4 equals minus the square root of -8, or 3k plus 4, I have an x there. 3k plus 4 is plus the square root of -8. Okay, so for this, we're going to need the square root of -8. So once again, we'll factor that radicand into perfect squares factors and not perfect square factors. -8 will be 4 times -1 times 2. That'll give us the square root of 4, the square root of -1, and the square root of 2. So we will have 2i square root of 2. So we have 3k plus 4 is -2i root 2, or 3k plus 4 is plus 2i root 2. All right, so then to finish this, to isolate k, we should subtract 4 and divide by 3. So this will give us, I'll do it in 2 steps. 3k is -4 minus 2i root 2, and then divide by 3. So this will be -4 minus 2i root 2 divided by 3. Follow the pattern, same thing for the other one. We will end up k is -4 plus 2i root 2 all over 3. All right, last example we'll have is, 9x squared minus 12x plus 4 equals 25. So on this one, what you'll want to do is recognize that the left side is a perfect square and then factor it. So it may have been a little while since you've done that. So let's work our way through it. 9x squared is a perfect square, right? It is 3x squared. And the 4 that's in the back is 2 squared. And then that -12x we have in the middle, that's -2 times the 3x. So what we're getting at here is the perfect square trinomial formula. You may remember is a squared plus 2ab plus b squared, and that's equal to a plus b squared. So I was just trying to recognize 9x squared minus 12x plus 4 as a perfect square. Let me make it match by making it. There we go. So we can see that the left side here is a perfect square. It's 3x minus 2 squared. And then the right side there is 25. So the key step on this one is recognizing that that left side was a perfect square and then making it so that we can then factor. So now it's downhill from here. We'll have 3x minus 2 is plus or minus the square root of 25. 3x minus 2 is The square root of 25 is 5, right? So we'd have plus or minus 5. And so we have 3x is equal to 2 plus or minus 5. And so then x is 2 plus or minus 5 over 3. So this one's kind of neat because we end up with rational number solutions. Let me write them both down. I'll take the plus first. 2 plus 5 is 7. That would give us 7/3. 2 minus 5 is -3. -3 over 3 is -1. When you get rational number solutions, like happened here, but not the two yellow highlighted ones, for example, when you get rational number solutions, that means that you could have factored it in the first place. So let's see how that might have looked. If we had 9x squared minus 12x, and then that would be minus 21 equals 0. And so here there's a common factor of 3 that we could divide out. So it would look like that. We would have had 3x squared minus 4x minus 7 is 0. And then if you remember back to factoring, maybe by grouping, we'll try that. We'll have 3x squared minus 7x plus 3x minus 7 is 0. Here I looked for two numbers that multiplied to be the same as 3 times -7. That's -21. And added to be -4, and that would have been -7 plus 3. So factoring the x out in front, we'll have 3x minus 7. And then the 1 in the back, that's just 3x minus 7. So we'll get x plus 1, 3x minus 7. And I'll leave it to you to use the zero product property to finish. And then you'll see that you would end up with the 7/3 and -1. So with the point here is that when you get rational number solutions, you could have factored, but by then it's too late. And you may not have preferred to factor anyhow. All right, so that takes us to the end of section 9.1 on solving quadratic equations using the zero product property. Let me know if you have any questions, and have a great day.